Start with our star, and we find the last 24 hours with only one M-class flare, but it was not a traditional one. On the left, it was an umbral magnetic interaction surge between the northern and southern sunspots. Definitely don't see that every day, even at sunspot maxima. Couple large plasma filaments there as well. Let's go ahead and take a look at those sunspots. Big group coming over the left there. And what you can't see yet is that the northern grouping actually continues back over the limb a bit. There's even more to that active region that we have coming. In 304 angstroms, we will see the interaction surge brightening the chromosphere over in that area. Definitely a solar watch for these incoming groups. And let's take a moment to peek back 2 years ago at what the sun looked like during its early ascension phase of the cycle. Just a couple sunspots here and there at high latitude compared to now. This is what solar maximum looks like, and it's why we've had so many more solar flares recently. Again, the active regions incoming from the left are big, complex, and interacting across the equator, which is not exactly the most normal thing to see, even at sunspot maximum. Folks, this paper really caught my eye yesterday. A very remote Antarctic station for monitoring the geomagnetic field. So remote, they can only get there once a year to download the data. They say it's largely for monitoring space weather and to increase the coverage of the southern hemisphere stations since there are currently so many more monitors in the north. But then why make it so remote? Why put it where there's no chance of the space weather-induced currents affecting anything relevant? My bet is this is to monitor the magnetic pole shift, as there is a rationale for putting the station there if that is the real goal.